All right, welcome to video number 2. We did the first 3 examples looking for patterns in the numbers, the list of numbers that we call a sequence. The sequence of numbers, we found a pattern to the values, right? When I get to number 4, and I highlighted number 4 and number 9 specifically, when I get to number 4, I notice that the numbers are getting bigger, right? But I don't know if there is a number that I'm adding or subtracting. So they're getting bigger, right? I don't think there's a number that I'm multiplying that's the same number over and over again. Because if I start with 1 and multiply by 4, that'll give me to 4. But then 4 times 4, well, that would give me to 16, and I have a 9. And then 9 times 4 give me 36, and I have 16. So I don't think it's multiplication. So then the second question is there a number that I'm adding? Well, if I add, let me use this color. If I add, I would have to add 3. That'll give me to 4. And then I could add, but if I add 3, that's going to give me to 7, and that's not going to be the answer. And if I were to add 3 to 9, that's going to give me to 12, and that's not what's next. But I do notice this. To get from 4 to 9, I have to add 5. And to get from 9 to 16, I have to add 7. So the pattern here is not that I'm adding the same number over and over again, but I'm adding special numbers. What kind of numbers are these? And can you predict what the next number would be that I would add on? What kind of numbers are 3, 5, 7? What would be the next number? If you thought 9, you are correct. If you add 9 to 16, I believe you get 25. Now wait, what kind of numbers are those? Those are all odd numbers, right? 3, 5, 7, 9. So the next number I would add would be 11. The next number I would add would be 13. So is there a pattern? There is a pattern. But it's not like the other patterns where I'm adding or subtracting or multiplying or dividing by the same number. But there is a pattern to the numbers that I'm adding. So I'm going to say we're adding consecutive, meaning back to back, odd numbers. Right? We're adding consecutive odd numbers. 3, 5, 7, 9. The next one would be 11. So how would I figure out the 10th term? Well, let's go to our calculator. So here I'm not going to be able to do that shortcut because we're adding different numbers. So I'm going to start with the first one. We're going to add 3. That's how we got this. So that's the second term. And then we're going to add 5. And that's the third term. Add 7. That's the fourth term. Add 9. That's the fifth term. Now, some people, if I stop right there, you might find a pattern with these answers, with these numbers, right? But we're using the odd number sum here, or the odd number addition. So then the next one would be 11. So this is the sixth. And then the next one, I have to add 13 because that's the next odd number. And then the next odd number. And then the next odd number. I think I'm at 9. And then the next odd number, and that's going to get me to the 10th one. 100. That would be the 10th term. 100. Now, later we're going to come back when we talk about what's called explicit formulas and say, hey, there's another way we could have gotten that, right? But for right now, since we're looking to see what's the value that we're adding, subtracting, multiplying, dividing, the pattern that we found was that we're adding odd numbers, consecutive odd numbers, right? 3, 5, 7, 9, 11, 13, 15, and so on. Cool. Let's jump to number 9. So when I go to number 9, again, I notice that the numbers are getting bigger. So that means I'm either adding or multiplying. So to go from here to here, to go from here to here, to go from here to here. But I do want you to notice that the jumps between terms, the jumps between the numbers are getting bigger and bigger and bigger. So I don't think we're adding the same number over and over again. And you can check pretty quickly because you can say to get from 1 to 2, we added 1. To get from 2 to 6, we added 4. To get from 6 to 24, we added 18. Oh, that's a big jump. And there's no pattern there. Okay, so does that mean we multiplied by something? I don't know. To get from 1 to 2, we multiplied by 2. To get from 2 to 3, we multiplied by 3. To get from 6 to 24, we multiplied by 4. Do you notice a pattern now? 2, 3, 4. What would be the next number that we would multiply by? Did you say 5? Because I think it is. If you multiply by 5, then that's going to get us to 120, and that is the fifth term. So it turns out that there is a pattern, but we're not multiplying by the same number, but there's a pattern to the numbers that we're multiplying by, and we can say we're multiplying consecutive, meaning back to back, right? Consecutive whole numbers. I multiply by 2, then multiply by 3, then multiply by 4, 5. So if I want to get to the 10th term, I got to keep multiplying by consecutive terms. So here I'm going to start from where we left off, which was 24. I'm sorry, this was the 4th term. And then we multiplied by 5. That got us to the 5th term. And then this is going to get us to the 6th term, to the 7th term, to the 8th term, to the 9th term, to the 10th term. 3,628,800. 3,628,800. 3628,800. I'm saying that out loud because, gosh darn it, that's a big number. 32. Oh, I already forgot it. That's how big a number it is. I forgot it. What is it? 3628,800. 3628,800. So here is our ginormous 10th term. 3,628,800 would be our 10th term. How did we find that? Because there was a pattern. The pattern maybe wasn't multiplying by the same number, but it was multiplying by a pattern of numbers, and the pattern of numbers were just consecutive whole numbers. That can happen as well. So what I'm going to ask you to do is I would like you to do numbers 5, 6, and 8 on your own and see if you can figure out the pattern for those. And then maybe at the end we can check them. But definitely with your partner, with your neighbor, see if you can do 5, 6, and 8. Actually, see if you can do 5, 6, 7, and 8. Yes, let's do those. Just finding patterns. In the next video, we'll take a look at patterns using shapes.